In the first part of section 2.1, you solved linear equations. In the second part, you're going to solve linear inequalities. And they're very similar except for if you have to multiply or divide by a negative number. So hopefully you remember that from Algebra 1. So let's just talk about what an inequality is. It's a mathematical statement that compares two expressions by using the symbols less than, greater than, less than or equal to, greater than or equal to. You can see some other ones like not equal to, but these are the four most common inequality symbols. So those are the ones you'll be mostly using in section 2.1. Okay, the solution set of an inequality is the set of all points on the number line, and this is different than an equation. With an inequality, we're talking about a number line that satisfy the inequality. So, difference between equations and inequality. An equation, you're either going to have x equals a number. You'll have the identity, so if you have 5 equals 5, that would be the identity. Or you will have a contradiction, 5 equals 4. But with an inequality, you're going to have values on the number line. So if we have x is less than or equal to 3, that means it's going to be 3 and all of the numbers less than that. So all of the properties of equality are also true for inequalities, with one very important difference that I mentioned before. If you multiply or divide by a negative number, you must reverse the inequality sign. Now, sometimes students want to reverse the inequality sign for everything, but it's just if you're multiplying or dividing by a negative number, then you reverse the inequality sign. So when you're graphing on a number line, less than, greater than are the inequalities that go with an open circle, and less than or equal to and greater than or equal to are the inequalities that go with a closed or filled in circle. All right, so I'm going to give you a couple of examples. The first one I'm going to do two different ways. We have this inequality, and first I'm going to move the variable over to the left side. Now you can move it over to the right hand side if you want to, but I'll show you what I see a common mistake when students do that. So if you want to do that, just be aware of what I tell you towards the end of the question here. So first thing I'm going to do is I am going to move the 13a over to the left. And usually if you move the variable over to the left, less mistakes are made. But you can move it over to the right if you want, and I'll show you on the other side. So we subtract 13a from both sides, and we end up with a negative 5a minus 2 is greater than or equal to 8. And then we add the 2 to both sides and get negative 5a is greater than or equal to 10. Now, since we're dividing by a negative number, we have to reverse the inequality. So now it becomes a is less than or equal to negative 2. And when you graph that on a number line, just put a 0 and then the number, whatever it is. If it's a negative 2 to the left, if it's a positive number, put it to the right of 0. And make sure that you understand that if there's part of that equal sign with the inequality, then the circle has to be closed. Now, if you would like to move the variables over to the right side so that they stay positive, your variable stays positive, you just need to be careful when you get down to here. This is where a lot of students make mistakes. If you get down to here, you want to make sure that you don't do this. Like I'll have students say negative 2 is greater than or equal to a. Oh, we need to put the a on the other side, so they do this. A is greater than or equal to negative 2. This reads from left to right. A is less than or equal to negative 2. So you need to write it like this, not like that. So just be careful if you're putting the variable on the right-hand side. Okay, the second example is to solve and graph this inequality. So again, I'm going to just do this one way this time, but you can do it either on the left-hand side or the right-hand side. Just being careful about this inequality. When you flip the numbers, the number and the variable, also flip the inequality so it stays correct. All right, I'm subtracting 4x from both sides, which is going to give me a negative 3x plus 8. Subtracting 8, I end up with a negative 3x is less than 9. And dividing by a negative 3, I end up with x is greater than negative 3. So when I write my solution, I can represent that on a number line Since this is less than, my circle is going to be open at -3, and the arrow is going to be pointing to the right. Okay, you have 2 questions to do on your own for the You Try It section.